Hi everyone. Today we will do some problems on ILD for simply supported beam. A simply supported beam has a span of 6 meter. Draw ILD for reaction, shear force and bending moment at a distance 4 meter from left support. I have drawn a simply supported beam AB of span L is equal to 6 meter. And it is asked to find out the ILD for reaction, shear force and bending moment at a distance 4 meter. That is, a section is at 4 meter distance from support A. So first we are going to find out the ILD for reaction. First one is ILD for RA. So at A it is 1 and at B it is 0 and so is the plot. Next ILD for RB, at A it will be 0 and at B it will be 1. Next we are going to plot the ILD for shear force at section. Already we have gone through a trick to draw the shear force. That is, we have to draw a line through this section and join both the ends. Bottom point it is Z by L, top point it is 1 minus Z by L. Together, if these two gives a summation of 1, what we have done is right. This portion is negative and this portion is positive. So, this is the plot of ILD for shear force at C. Next, we will plot the ILD for bending moment at C. This is point A and this is point B. Corresponding to the section, the equation is Z by L into L minus Z. On substituting, we get it as 4 by 3. So, together, these are the plots of ILD for reaction, shear force and bending moment. But for scoring full marks in descriptive exam, you have to write the equations and steps. Next, we will see how we can draw ILD for simply supported beam with UDL. A simply supported beam has a span of 5 meter. Here I have drawn a simply supported beam AB of span 5 meter, carry a UDL of 25 kN per meter throughout. UDL is drawn. Draw ILD for shear force and bending moment. Find its value at 2 meter. That is, section is at a distance of 2 meter from left support. I have marked C, the section at 2 meter distance from A. To plot ILD for shear force at section, I have drawn a line through the section. Bottom point is Z by L, top point is 1 minus Z by L. Now join to both the ends. Together, if this 2 by 5 and 3 by 5 gives a summation of 1, then this plot is right. Now to plot the ILD for bending moment at section, at this point, equation is Z by L into L minus Z, which gives 6 by 5. Now, we are asked to find out the shear force and bending moment at a distance of 2 meter from the left support. Equation of shear force at section is load into area of ILD for shear force. This equation is used since the loading is a UDL. The load is 25 kN per meter. It's already given in the question. It is 25 into area of this portion plus area of this portion. It is 25 into area of this portion plus 25 into area of this portion. It is 25 into, the area will be half BH since it is a triangle. Half into base 2 meter and altitude minus 2 by 5. And the other portion half into base is 3 meter and altitude is 3 by 5. Together gives a value of 12.5 kN. Now the equation for bending moment at C can be written as load into area of ILD for bending moment. The area can be written as sum of area of two triangles. Now load 25 kN per meter into half into base into altitude plus half into base into altitude. On substituting values, we get bending moment at C as 75 kN meter. Next, we shall solve the problem of a simply supported beam with the combination of point loads and UDL. 4 equal loads of 80 kilonewton each. So I have drawn 4 80 kilonewton loads equally spaced at 2 meter apart. Each 80 kilonewton is at a distance of 2 meter from each other, followed by a UDL of 60 kilonewton per meter. So the 80 kilonewton loads are followed by a UDL at a distance of 2 meter from the last 80 kilonewton load. From the last 80 kilonewton load at a distance of 2 meter, I have drawn 60 kilonewton per meter, and the girder span is 20 meter from right to left. That is, the load is moving from right to left. So the first load is this 80 kilonewton and the last load is this UDL 60 kilonewton per meter. Calculate shear force and bending moment at the section 8 meter. So the section is at 8 meter from left end support when the leading load 80 kilonewton, that is the first load 80 kilonewton, is 5 meter from the support. That is, the first load 80 kilonewton is at a distance of 5 meter from end A. It is asked to calculate the shear force and bending moment at the section. Now, to plot the shear force, draw a line through the section and join both the ends. This is the ILD for shear force. Draw lines corresponding to all the loads and mark them as F1, F2, F3, F4 and F5. Now the equation for shear force can be written as load into corresponding intercept in ILD for point load and load into area of ILD for UDL. That is, $80 kilonewton into F1 plus 80 into F2 plus 80 into F3 plus 80 into F4 plus 60, which is the UDL, into area half into base 7 meter and altitude F5. In order to find the values of F1, F2, F3, F4 and F5, we have to use the concept of similar triangles. To find out F1, we have to take this small triangle and this big triangle. Point 4 upon 8 meter distance is equal to F1 upon 5 meter distance, and F1 comes out to be 0.25. To find out F2, we have to take this small triangle and this big triangle. 0.4 upon 8 is equal to F2 upon 7 meter distance, and F2 comes out to be 0.35. Next, in order to find out F3, we have to take this small triangle and this big triangle. 0.6 upon 12 is equal to F3 upon 11, and F3 comes out to be 0.55. To find out F4, we have to take this small triangle and this big triangle. 0.6 upon 12 is equal to F4 upon 9 meter distance, and F4 comes out to be 0.45. Now the last one, F5, we have to take this small triangle and this big triangle. 0.6 upon 12 is equal to F5 upon 7, and F5 comes out to be 0.35. Now shear force at section becomes 80 into minus 0.25. That minus, since this portion is minus, F1 and F2 are negative, so minus 0.25, plus 80 into minus 0.35 plus 80 into 0.55. This is F3. This portion is positive, therefore F3, F4, F5 are positive. Therefore 80 into 0.55 plus 80 into 0.45, this is F4 plus 60, that is load into area of ILD. That's a triangular portion, therefore half into base 7 meter distance, and height is F5, that is 0.35. Together the value comes out to be 105.5 kilonewton. Next is the ILD for bending moment. This is the plot for ILD for bending moment, and the equation is Z by L into L minus Z, which is 4.8. Draw lines corresponding to each loads and mark it as M1, M2, M3, M4 and M5. Bending moment at C can be written as 80 into M1 plus 80 into M2 plus 80 into M3 plus 80 into M4 plus UDL into area of ILD for bending moment. These M1, M2, M3, M4 and M5 are all positive. Here we have to use the concept of similar triangles to find out the values of M1, M2, M3, M4 and M5. To find out M1, choose this small triangle and this big triangle. 4.8 upon 8 meter distance is equal to M1 upon 5, and M1 comes out to be 3. To find out M2, choose this small triangle and the big triangle. 4.8 upon 8 is equal to M2 upon 7, and M2 comes out to be 4.5. To find out M3, M4 and M5, choose this big triangle. To find out M3, choose this small triangle. 4.8 upon 12 meter distance is equal to M3 upon 11, and M3 comes out to be 4.4. To find out M4, choose this small triangle and the big triangle. 4.8 upon 12 is equal to M4 by 9 meter distance, and M4 comes out to be 3.6. Similarly, to find out M5, choose this small triangle and this big triangle, and M5 comes out to be 2.8. Substituting in the equation framed for bending moment with all the M1, M2, M3, M4 and M5 as positive, we get the value of bending moment at section as 1804 kilonewton meter. And we are done with the question. Thank you.